Section 3.9 is derivatives of exponentials and log functions. So let's look. Our first rule is the derivative of e to the x. Again, this e to the u is e to the u du dx. That's our chain rule. Okay, so this is one you've seen before, I know. And here's a quick example. So our chain rule or inside function is x cubed. So it's e to the u du dx, which is e to the x cubed times 3x squared. Pretty cut and dry. Now, if u is a differentiable function of x and we have a different base than e, so a to the u, it's a to the u ln a and then our chain rule du dx. This actually is the exact same rule as my base e. So if I have base e and use this rule, you know that ln e equals 1, so we don't even have to bother with it. So our e to the x rule is exactly the same as this, we just don't have to write ln e every time. So if that makes it easier to remember this rule, it's really not two individual rules, it's the same rule, just without writing ln e. Alright, so the derivative of ln x, again, written as ln u so that we can use the chain rule when necessary, but the derivative of ln x is 1 over x. So let's again do an example here. So again, identifying our inside function and using y prime is 1 over this inside function times the derivative, chain rule, and we end up with this for our value, and simplified becomes just 2 over x. So some pretty simple examples. Okay, so that's ln and e. If u is a differentiable function and we're doing log base a of u, then again, just like we did when we changed from e to the x, and we didn't have to include our ln e, when we change from a different base than ln, we have to include our ln a. Sorry. So this is for any other base log. And this rule, the top's cut off again. The power rule for arbitrary real powers. They call it rule number 10. The power rule for arbitrary real powers. It's just using our power rule again, but saying that this works for any power, not just integers or rational functions. So let's look at an example. So here's one where the power is a little bit different than we usually see. So using the power rule, we first bring the power down and subtract 1. And of course there's our chain rule times 5. Cleaning it up a little bit, we like to put our coefficient in the front, and there's the power. So if you cannot subtract 1 from the power, just write the power minus 1. Okay, logarithmic differentiation. Sometimes the properties of logs can be used to simplify the differentiation process, even if logs themselves must be introduced. So in other words, it may not be a function with a log in it, but we might introduce the log in order to make differentiation easier. So the process of introducing logs is called logarithmic differentiation. This is often used when the variable is found in the base and the exponent. So if we have a variable both in the base of an expression and in the exponent of an expression, we're going to introduce logarithmic differentiation, and you'll see why as soon as we go through it. And I know you've done this before. So here's an example where we've got a variable in the base and in the power. So the first thing I'm going to do with this function is to write ln of both sides, take the log of both sides. And we use ln because it's much easier than any other base. So again, rewriting this, I can now bring the power down in front. Now I have a product rather than a base to a power where we have two variables. So now I can use a product rule rather than having to figure out how to differentiate a complex function like this. So, taking the derivative of both sides, on the left we get 1 over y dy dx. Don't forget that this is a chain rule now because we're differentiating with respect to x. Product rule, the derivative of the first times the second, plus the first times the derivative of the second. I now am going to multiply both sides by y to isolate my dy dx. However, I do want this in terms of x, so in going back to the beginning, I'm now going to take my y value and substitute it, and now I have a derivative for dy dx with all written in terms of x. It's not very nice and neat, but that's how we get there. Okay. The next few slides, that's the end of section 3.9. The next few slides are a chapter test. You can scroll through and try this now as a review. You can just stop the video now and use this later, but I'm going to go ahead and just scroll through. The first two slides are the test. So if you want to pause and try these problems, or at least look through, see if they look familiar, see how comfortable you are. And the last two slides are the answers. So I'm just going to scroll through this. You can use this in any way that you like. So there's the beginning. Again, pause if you want to actually try these. There's the last question. After this come the answers. So here are the solutions, and more solutions, and the end of the solutions. And that's it.